So in the previous video we missed this question number 69. We will see this now and then we will continue from where we left in the last video. So the question number 69 is from analog circuit. This is from JFET topic. So the question is N channel JFET has IDSS 2 milliampere, right? So IDSS, that is drain to source saturation current, we are given is 2 milliampere, and VP, this is nothing but threshold voltage, we are given is 4 volt. Its transconductance GM we have to find out. So we have to find out GM for an applied gate to source voltage. So gate to source voltage we are given is minus 2 volt. Okay. So we know GM is del ID divided by del VGS. Okay. And for JFET ID we know this is IDSS 1 minus VGS by VP whole square. Okay. So let us differentiate this ID with respect to VGS. So if we differentiate this, we will get IDSS, it is constant, and then 2 1 minus VGS by VP, and another term will be minus 1 by VP. Okay. So this is going to be minus 2 IDSS by VP and 1 minus VGS by VP, right. So we know IDSS, we know VP, we know VGS. Let's put all the values here. So we will get GM equals to minus 2 IDSS we have 2 milli divided by VP we have minus 4, and then 1 minus VGS we have is minus 2 and VP is minus 4. So 2 2s are 4, this will be 1 by 2, and 1 minus 1 by 2 will be 1 by 2. So this is going to be 1 by 2 into 4 will get cancelled out, this is going to be 1. So we got minus, not minus, this is plus 0.5 milliampere per volt. So GM we got 0.5. So the correct option with this we will have is A. Now let us go to next questions. So in the previous video we had seen up to question number 81. Now we will start with question number 82. So in the question number 82 we have two lists. One is list 1, another is list 2. So we have to match 4 option of list 1 with 4 option of list 2. So the option A is in list 1, option A is power efficient transmission of signal. So in conventional AM the power is P total equals to PC plus PM by 2. So apart from this carrier power, PM by 2 term is also there. But in case of FM, if nothing is given, we take the case of wideband, that is beta greater than 1. So in case of wideband FM, power is PC. So a power efficient transmission signal is in case of FM. Okay. Second, B option is most bandwidth efficient transmission of voice signal. So in case of single sideband suppressed carrier, bandwidth is lowest. So SSB SC will be matched to this B option. Now see the simplest receiver structure. So simplest receiver structure in case of conventional AM we use, that is envelope detector. So this will be matched with first one. And the D option is the bandwidth efficient transmission of signal with significant DC component. So apart from SSB SC bandwidth, there is a vestigial component in VSB. So that is DC component. So this will be matched to third one, right. So D is matched to third one, D is matched to third one, and A was matched to second one, right. So with this correct option will be B. Now let's go to next question, question number 83. This question is again from analog circuit. So the question what we are given is assuming the op amp to be ideal. Okay. So op amp is ideal, it means that inverting terminal current will be 0 ampere and non-inverting terminal current will be 0 ampere, right. And we see there is a negative feedback, so virtual ground concept will be valid here. So this is V0, okay, this is 0 volt, so this will also be 0 volt, right. And what we are asked, the voltage gain of the amplifier we have to find out. Okay. So at this node simply apply KCL. Okay. So applying KCL, then incoming current is Vi minus 0 by R1, this is incoming current, equals to outgoing current will be 0 minus V output by R2. So from this V output by Vi, that is gain, if you find out, this will be minus R2 by R1. Okay. So correct option will be A. Let's go to next question number 84. So question number 84 is from control system. The open loop DC gain of unity negative feedback system with closed loop transfer function. So open loop DC gain we have to find out. So closed loop transfer function CS by RS we are given is S plus 4 by S square plus 7S plus 13. So if we say this is a numerator by denominator, then directly shortcut we have to find out OLTF. GS is numerator by denominator minus numerator, right? So this is going to be s plus 4 by s square plus 7s plus 13 minus s minus 4, right? So this is going to be s plus 4 by s square plus 7s minus s, this is going to be 6s plus 13 minus 4, this is going to be 9. So we have to find out DC gain of this OLTF. So to find out DC gain, what we do is we put s equals to 0 in this GS. So if we put s equals to 0, this will be 0, this will be 0, this will be 0. So we will be left with 4 in numerator and 9 in denominator. So correct option will be 4 by 9. So answer is B. Let's go to next question 85. This is from network theory topic from transient. So this is what we are given in the circuit shown below. Switch SW is closed at t equals to 0. So this switch is closed at t equals to 0, but at t less than 0 this switch was open, and what we are given for initial condition, there are assuming 0 initial condition, the capacitor voltage VCT is, so we are given 0 initial condition. So VC0 equals to VC0 minus equals to VC0 plus R0. Okay, now let's make the circuit at t equals to infinity. Okay, so at t equals to infinity, what will happen? The switch is closed. Yes, this switch is closed, and this 10-volt battery is still there, and this 10-volt battery is connected through this 3 ohm and then this 2 ohm to this capacitor. Okay, so this 10-volt battery is connected for a long time to this capacitor. Then what will happen? This capacitor will be fully charged, and at a steady state this capacitor will be open, right? So this capacitor will be open. So VC infinity we have to find, right? So whatever current which is coming from this 10-volt battery will be coming in 3 ohm, then will be going in 2 ohm. So no current is going in this branch. Then effectively this 3 ohm and 2 ohm are in series. Then we can apply voltage division rule and find out VC infinity, because effectively this node voltage is nothing but VC infinity, right? So VC infinity, you can apply voltage division rule. Then this is going to be 2 by 2 plus 3 and then 10. Okay, this is 5 2s are 10, this is going to be 4 volt. So we found VC infinity 4 volt. Now let us find out the time constant. Tau equals to R equivalent into C equivalent, and C equivalent we are given 5 by 6. So this is 5 by 6. Now we have to find out R equivalent. Okay, now how do we find out R equivalent? To find out R equivalent, we know we make circuit at t greater than 0. Okay, and this will be closed, and to find out R equivalent, that is Thevenin resistance, we remove the independent sources. So independent sources is 10-volt battery here, so this will be sorted. Okay, and we will look at from this capacitor, then effectively this 2 ohm and 3 ohm will be in parallel, right? So this will be 2 parallel this 3, and then it will be 3 to the 6 by 5. Okay, so if we put R equivalent and C equivalent in this tau, we will get R equivalent is 6 by 5 and C equivalent is 5 by 6. So tau is 1. Now apply the transient equation. So we know transient equation is VCT equals to VC infinity plus VC of 0 plus minus VC of infinity and e to the power minus t by tau. Okay, so let's put all the values here. So VC infinity we know this is how much, 4, plus VC0 is 0 minus VC infinity 4, e to the power minus t by tau is 1. So from this you will get 4 minus 4 e to the power minus t. So this is the capacitor voltage. So correct option is A. Now let's go to next and last question from this slide, that is question number 86. So question number 86 is from communication system from sampling topic, and we are asked the Nyquist sampling interval. So before that we should find Nyquist rate or Nyquist frequency. So Fs is 2f maximum component, right? So from this we will find out Nyquist interval also. So we know the signal we are given xt is, actually there is a mistake in this question, this is also sync. So this question is copied from PYQ. So this signal was sync of 700 t plus sync of 500 t. So this was the actual question. Then we can write this sync in terms of sign. How do we write it? This will be sine of 700 pi t divided by 700 pi t. Okay, similarly the second term will be sine of 500 pi t divided by 500 pi t. Okay, so this is our xt, and we have to find out maximum frequency component in this signal, and there are two frequency component. So from this f1 you will write this is going to be 700 pi by 2 pi, so this will be 350, and this second frequency component f2 will be 500 pi by 2 pi, this is going to be 250. So from this f1 and f2, so maximum frequency is f1, right, that is 350. So a Nyquist rate fs, if you find out, this is greater than or equals to 2 f of maximum, and f maximum is 350, so this will be greater than or equals to 700. So this is Nyquist rate, and Nyquist interval will be less than or equals to 1 by 700. So maximum Nyquist interval will be 1 by 700. Okay, so correct option with this we will have is C. Now let us go to next questions. Next question is question number 87. This is again from communication system. This is a theoretical question. So the question is, in commercial TV transmission and picture and speech signal are modulated respectively. So picture signal are modulated, we know, using vestigial sideband, and speech signal or audio signal are FM signals, right? So VSB and FM is going to be correct, then C option is right. Next question is question number 88. Again this is a theoretical question. In EM wave, if EM wave is traveling, we know electric field is perpendicular to magnetic field is perpendicular to direction of propagation, right? So all these three are perpendicular to each other. So in the question we are given, in a traveling electromagnetic wave, this is E. So in traveling electromagnetic wave, E and H vectors are perpendicular in space, right? So A option will be correct. Next question 89. This question is, which of the following demodulator can be used for demodulating the signal xt equals to AC 1 plus kAmt cos 2 pi fct. So this is conventional AM expression, right? So in case of conventional AM, let us find this is AC 1 plus kAmt into cos 2 pi fct. Okay, so if we compare with given expression, then AC will be 5 and kAmt. Okay, so this kAmt is how much? This is 2 cos 200 pi t, right? So if, and we know mu, modulation index mu equals to Ka mod of mt maximum, right? So effectively maximum value of this will be K, so will be mu. So mu will be its maximum value, if you find out, that is 2. So mu is greater than 1, so this is over modulation case, right? So for over modulation, envelope detector demodulator we cannot use, because for envelope detector mu has to be less than or equals to 1, right? So square law demodulator, no, for square law modulator we use, then this, for this appropriate will be a synchronous demodulator. So for question number 89, correct option will be C. Question number 90. The question is, a system with input xt and output yt is described by relation yt equals to txt. Okay, and we have to find out a linear and time invariant system. Okay, we have to comment on linearity and time invariance, whether the system is time invariance or not. So we know, I have already made a video on it, like if the shortcut is, if output equals to some function of time plus minus input, that is xt, or if output equals to some function of time into xt, or if there is a basic function inside this x, some basic function, that is if time reversal, time scaling. So if any other basic function, then if these conditions are there, or any of these conditions are there, then directly we can conclude that the system is time variant, right? Similarly for linearity, so there were the two conditions for linearity or non-linearity checking also. The first condition is there is no non-linear operator, there is no non-linear operator. If there is a no non-linear operator on xt, that is on input, there should be no non-linear operator. And second condition was, if you put xt equals to 0, then you should get output equals to 0. If these two conditions are satisfied, then you could directly conclude that system is linear. Okay, so with this, let's go to the question. So the question is yt equals to t into xt. if you observe, then some function of time into xt is there, then this is going to be time variant. Okay, and if you see, there is no non-linear operator on xt, only simple xt is there, and if you put xt equals to 0, then yt will also be 0. So this is time variant, but linearity condition is satisfied, so this is time variant and linear. So this is linear and time varying, so correct option will be B. Let's go to next question, question number 91. For the logic circuit shown below, the required input condition ABC to make the output x equals to 1. So we are given output x equals to 1, and we have to find out what is going to be input ABC. So we can go with this question, we can go with the options. So if you put 1 0 1, okay, so if A is 1, B is 0, C is 1. Let us see what will happen. So 1 0, this is XOR, XOR will be what? 1, right? And then this is 0 1, this is XNOR, XNOR will be 0. So if anything is 0, then this will be 0. So A of 1 will be wrong because we are getting 0. Now let us go to B of 1. So similarly, if you check B of 1, this is 0 0 1. So 0 0 will be 0, and this is 0 1, this will also be 0. Or anything is 0, you will get 0. So B of 1 is also not correct, right? Now let's see what about C option. So C option is 1 1 1. So 1 1 1. If these two are 1 for XOR gate, this will be 0. If these two are 1, this will be 1. So if anything is 0, this will be 0. So C option is also not correct. So if you check for D option, 0 1 1, 0 1 1. So 0 1, this will be 1, and for 1 1 XNOR gate, this will be 1, and C is 1. So all are 1, then this will be 1. So correct option will be D. So such type of question you could go with the options. Next question is question number 92. The question is, an AM signal is detected using an envelope detector. Okay, the carrier frequency and modulation signal frequency are 1 megahertz. Okay, so AM signal we are given, and the carrier frequency we are given is how much? 1 megahertz. Okay, and modulation signal frequency, that is FM, how much? 2k. Okay, an appropriate value for the time constant of envelope detector. We know for envelope detector the time constant range is, it should be greater than 1 by fc, and it should be less than 1 by fm, right? So tau will be 1 by fm means 1 by 2 milli. This is k, this will, its reciprocal will be milli, right? So 1 by fc, this will be 1 by 10 to the power 6, right? So 10 to the power minus 6 second to 0.5 millisecond, right? So this is 1 microsecond to 0.5 millisecond. In this range, our time constant should be for envelope detector. Okay, now let us check out the options. This is a 500 microsecond, or this is 0.5 millisecond. Okay, so this is extreme value, this is not correct. And 20 microsecond, between 1 microsecond and 500 microsecond, so this can be the correct, and 0.2 no. So correct option will be B. So let us go to next question number 93. So question number 93 is from analog circuit, again from full wave rectifier. So the question is, in a full wave rectifier, if the input frequency, okay, so for full wave rectifier, if we give this input, right, so output we get is, for both the cycle we will get output, right? So like this we get. So if its frequency is f input, then its frequency will be 2 times of that, so 2f input, right? So if the input frequency is 50 hertz, then output frequency will be 2 times of 50, so 2 times 50, so output frequency will be 100 hertz. Okay, simple question. So correct option is C. Now let's go to next question, and this question is from mathematics. Okay, so the question number 94 is the maximum value of the function fx. So fx we are given, that is ln 1 plus x minus x, and we have to find out its maximum value, and we are given where x is greater than minus 1. So we have to find out at what value of x occurs at x. So we have to find out value of x at which maximum value occurs for this system, or for this function, right? So for this we will differentiate it, f dash x. So ln 1, this is going to be 1 upon 1 plus x minus 1, and we will put it 0. So this is going to be 1 minus x by 1 plus x square. Okay, this is going to be 0. So if we put it 0, then you will get x equals to 0, right? So let's differentiate one more time. So f double dash x is going to be what? This is going to be minus 1 upon 1 plus x whole square. Okay, so f double dash 0 will be what? Minus 1 by 1 plus 0 square, right? This is minus 1. So if f double dash 0 is less than 0, then at x equals to 0 will get maximum, right? So at x equals to 0 will get maximum. So the value of x at which this function is maximum is b, that is 0. So let's go to next question number 95. This is from analog circuit. So the question is cascade amplifier in multi-stage configuration is. So we have to find out what are the configuration of BJT there are. So there are we know in case of question number 95. So in case of cascade amplifier, so how the BJT are connected? One BJT is connected like this. This is VB1, okay, and one BJT is connected like this. This is grounded and this is VB2, okay. So this is common emitter because we are giving input and we will at base and we will be taking output from collector. So this is common emitter and this is common base, okay, because emitter is grounded, right, and this base is a DC. So there is a common emitter, common base. So B option is correct. Let's go to next question, question number 96. So question number 96 is the impulse response Hn of LTI system is given. So Hn we are given. So Hn is u of n plus 3 plus u of n minus 2 minus 2 u of n minus 7. Okay. So if you see, if this impulse response is represented in terms of step signal, and if sum of coefficient is 0, then we say this is finite duration, finite amplitude. If this is finite duration, finite amplitude, this will be absolutely summable, okay, this will be absolutely summable. And if impulse response is absolutely summable, then we say system is stable, okay. So if you see, this is its coefficient is 1, its coefficient is 1, its coefficient is minus 2. So sum of coefficient will be 1 plus 1 minus 2, that is 0. So if sum of coefficient for impulse response which is represented in terms of step signal, then if sum of coefficient is 0, then we can say this sequence is finite duration, finite amplitude, and it's absolutely summable, then we can say this is stable, okay. And for commenting on causality, then this system is also present for n less than 0, because this is starting from n equals to minus 3 also, right. So it is represent, so this Hn is not equals to 0 for all n less than 0, then this is not causal, okay. So this is not causal system, right. So we can say this is stable but not causal, so correct option will be A. So the next question is question number 97. So this question is again from Z transform signal and system. So the question is the Z transform Fz of the function fnt equals to a to the power nt. So we have to find out Z transform of this fnt. So fnt, or we can say fn, we are given is a to the power nt, okay. So we know Z transform Fz equals to summation n equals to 0 to infinity fn z to the power minus n, right. So this is going to be n equals to 0 to infinity, fn is a to the power nt and z to the power minus n, right. So n equals to 0 to infinity a z, okay. So we can write it a to the power t and z inverse, right, to the power n. Can we write like this? So e to the power p, e to the power t, z to the power minus 1, t to the power n. Yes, we can write. So put n equals to 0. So you will get anything to the power 0, 1 plus a to the power t z inverse plus a to the power t z inverse square. Okay. So this is a kind of GP. Then we can know. Then we can solve it. So this is going to be a upon 1 minus r, and r is going to be a to the power t z inverse. Okay. So this is going to be f of z is going to be 1 upon 1 minus a to the power t z inverse. Okay. So if we multiply by z, numerator and denominator, so we will get z upon z minus a to the power t. Okay. So z upon z minus a to the power t, then with this we will have correct option A. So A option will be correct of question number 97. Now let's go to next question, question number 98. So question number 98 is again from communication system. So the question is Consider a sinusoidal modulation in an AM system, assuming no over modulation. Okay, so assuming no over modulation, then mu has to be less than or equals to 1, right? So modulation index mu we have to find out when the maximum and minimum value of envelope. So envelope maximum value is 3 volt and envelope minimum value we are given is 1 volt, and we know formula for mu, that is E maximum minus E minimum upon E maximum plus E minimum, E maximum plus E minimum, right? So E maximum is 3, E minimum is 1, so 3 minus 1 by 3 plus 1, so it's going to be 2 by 4, that is 1 by 2, it means 0.5. So correct option will be A. So let's go to next question number 99. Okay, so in the question number 99, it's again from analog circuit, and the question is the circuit shown in the figure given below is. So we have to find out this about this circuit. So there is a positive feedback and input is given, so non-inverting amplifier no, an inverting amplifier no, an oscillator no. If it was oscillator then there should not be any input, so it's a Smith trigger. Yes, this is inverting Smith trigger because we are giving input at inverting terminal. So correct option is D. Next question, question number 100. The input and output of a continuous time system are respectively denoted by xt and yt. Then which of the following description correspond to a causal system? We know for a causal system, then output should be depend only on present and future, present and the past value of input, right? So let us check this. So in option A, then output is depending on future value. How? If you put t equals to 2, then y2 is going to be how much? X of 0 plus x of 6. So we are finding value at t equals to 2, but it is also depending on the value of input at t equals to 6. It means it is depending on future value of input. So this is not a causal system. Similarly, this is not causal system, this is not causal system, so this is causal system, right? So correct option will be C. Next question number 101. A 10 megahertz carrier is frequency modulated. So this question is, this is 101. This question is from FM, frequency modulated. 10 megahertz carrier. So FC we are given is 10 megahertz. Okay, by a sinusoidal signal of 500 hertz. So FM sinusoidal signal we are given 500 hertz. Let us say this is 0.5 kilohertz. Okay, the maximum frequency deviation being, so delta f maximum, that is maximum frequency deviation we are given is 50 kilohertz. Okay, the bandwidth required given by the Carson's rule. So we know Carson's rules, the bandwidth is 2 beta plus 1 into fm, right? And 2 we know beta, this is delta f maximum by fm. Okay, and plus 1 to fm. If you multiply fm, then this is going to be 2 delta f maximum plus fm. Okay, so 2 delta f maximum we are given 50k and fm we are given 0.5k. Okay, so this is going to be 250.5k. So this is going to be 101 kilohertz. So correct option is going to be A. Let us go to next question number 102. For a closed loop system shown below, the natural frequency we have to find out. Okay, so this is the second order system, and we know for a second order system, the unity negative feedback transfer function is going to be Cs by Rs is omega n square upon s square plus omega n square plus 2s zeta omega n. Okay, so from this if we write OLTF, that is going to be omega n square by s into s plus 2 zeta omega n. Okay, so if we compare this OLTF with this OLTF, so omega n is going to be 2 and 2 zeta omega n is going to be 4, right? So 2 2s are 4 and zeta will be 2 by omega n, 2, zeta is going to be 1. So what we are asked? We are asked natural frequency, that is omega n. So omega n was coming 2. So correct option will be C. So let us go to next question number 103. The question is, a system is defined by its impulse response Hn. So question number 103, we are given impulse response of discrete time system, that is 2 to the power n u of n minus 2. Okay, so this from this we can say that this system is existing from n equals to 2 to infinity, right? So we can say from this that hn is, so we can say that hn equals to 0 for all n less than 0, right? So from this we can conclude that system is causal, right? Now we have to comment on its stability also. So for hn to be stable, we know it has to be absolutely summable. Now let us find out summation n equals to minus infinity to infinity mod of hn. If this is less than infinity, then we can say this is absolutely summable and it will be unstable, right? So let us find it out. N equals to minus infinity to infinity. So hn is how much? This is 2 to the power n u of n minus 2. Okay, it means it is existing from n equals to 2 only, right? So limit will be n equals to 2 to infinity and 2 to the power n, right? Let's put the value of n. So n 2 to the power 2 plus 2 to the power how much? 2 to the power 3 plus 2 to the power 4 plus dot 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 2 to the power infinity, right? So this will not come out to be less than infinity. This is going towards infinity. So this is not converging, but it is diverging. So it will not come less than infinity. So this condition will not be satisfied. So we can say this system is not stable. Okay, because this will not be absolutely summable. So we can say the system is causal but it is not stable, right? So we can say this system is causal but it is not stable. So correct option will be B, that is causal but not stable. So let us go to next question, that is question number 104. So in 104 the question is again from communication system. So the question is a message signal cos 2000 pi t plus 4 cos 4000 pi t modulated the carrier ct equals to this much cos 2 pi fct. So fc we are given is 1 megahertz. Okay, to produce an am signal, so we have to produce am signal. Okay, for demodulating the generated am signal using an envelope detector, the time constant rc, so we know time constant range has to be 1 by fc. Okay, and should be greater than 1 by fc and less than 1 by fm. So fm we have two frequency component. This is 2000 pi t. So fm, so f1 from this if you divide, f1 will be, if you divide by 2 pi, this will be 1k. Okay, similarly if you divide it by 2 pi, you will get a 2k, right? This is 4000, you will divide it by 2 pi, then this is going to be 2k, this is going to be 1000, means 1k. So we got two component. So fm has two component, one is 1k and one is 2k. Okay, and fc is having 1 megahertz. So 1 by 1 mega means 10 to the power 6 less than tau less than 1 by fm. Okay, so tau has to be or less than equals to, you can put, so tau has to be less than equals to 10 to the power minus 6 second and 1 by, so two conditions are there. One is saying 1 by 1k and another is saying 1 by 2k. So it means this is has to be 1 millisecond and this is saying 0.5 millisecond. Okay, so this is let us say 0.5, this is 1. So this is saying less than 1 millisecond, this is saying 1 millisecond. So intersection will be less than 0.5, right? So tau will be less than 0.5 millisecond and greater than 1 microsecond. So this is going to be range of tau for envelope detector. So 1 microsecond, 0.5 millisecond. Then correct option will be B. Okay. So let's go to next question number 105. This is from analog circuit and the question is in a circuit shown below, the Zener diode is ideal and the Zener voltage is 6 volt. So Zener voltage we are given Vz is 6 volt and Zener diode is ideal. It means that Rz is going to be 0 or Iz minimum is 0. And we have to find out output voltage. So to find out output voltage, we have to know first whether this Zener diode will work in breakdown or not. It means that Zener diode is working under as a regulated voltage or not. So before that, let us assume this diode off. So I am assuming this diode off. Now let us find out voltage across it. If the voltage across it is coming greater than 6 volt, that is its Zener breakdown voltage. If greater than Zener breakdown voltage, then only this Zener diode will be in breakdown, otherwise it will not. Okay, let us find out this. So if it is open, then whatever current will be coming from this 10 volt battery will be going 1k and then 1k, right? So let us find out this VA first. Okay, so VA is going to be 1k by 1k plus 1k, because voltage division rule we are applying, and this is 10. So 1 by 2, 5 is 10, so VA we are getting 5 volt. So 5 volt is less than its breakdown voltage, right? So this Zener diode will not go in breakdown and this will remain open. So if it is open, then VA will be V output only, right? So V output is VA, which we just now found. This is 5 volt. So correct option will be 5 volt, that is A option. So let us go to next question number 106. The EM field and current is concentrated close to the surface of conductor. The phenomenon is called. We know when current distributed within a conductor, like if it is more at the surface and if it is less otherwise decreasing with the depth of the conductor, then this is called skin effect, right? So this was the theoretical question. Now let us go to 107. Two discrete time system with impulse response h1n. So h1n we are given del of n minus 1, and h2n we are given del of n minus 2. These two are cascaded. So we have two system, both are cascaded, right? So this is h1n and this is h2n. Okay, so if we find out Z transform, then this is going to be, we know delta n Z transform is 1, then del of n minus will be how much? So h1z we can find out, this is Z inverse. Similarly h2z we can find out Z to the power minus 2. We know if two systems are connected in cascade, then their impulse response, then their overall impulse response will be convolved of the individual one. Okay, so this is going to be h1n convolution h2n. Okay, so overall if I take its Z transform, hz will be what? h1z into h2z, right? So h1z is how much? Z inverse. h2z is Z minus 2. So you are getting Z minus 3, then hz you got Z minus 3, and hn if you take inverse Z transform, then it will be del of n minus 3. Overall impulse response is del of n minus 3. So correct option is C. Let's go to next question. Now question number 108. So question number 108 is from CMOS topic. So this is a simple question. We have to find out the expression of y. So this is A, this is B. We know if two NMOS are in parallel, then it will be A plus B. This is OR gate, and in series is C. So this is dot C, that is AND gate, and its complement will be final output. So A plus B dot C bar is going to be final output. This is B. So let's go to next question. This is IC fabrication topic. This is not in the syllabus of gate, so we'll leave it. Let's go to question number 110. So consider the Z transform we are given, okay, and we are asked the inverse Z transform. So it's a simple, right? So Z transform we are given is 5Z square plus 4Z inverse plus 3, right? We know delta n, this is question number 110. We know delta n Z transform is 1. So in time shifting, del n minus 1 is going to be, or del n minus k is going to be its Z transform is going to be Z to the power minus k. So similarly, let us do it here. So 5Z square, it means 5 of del of n plus 2, okay, and 4Z inverse, 4 of del of n minus 1, and 3, this is going to be 3 del of n. So correct option is 5 del of n plus 2. So I think there is a mistake. There should be del in all the option, there should be delta function, right? So 5 del of n plus 2, 4 del of n minus 1. So 4 del of n minus 1, and then 3 del n. So A option will be correct. Let's go to next question number 101. It's again from signal and system. A sequence action with Z transform we are given is applied as an input to LTI system, right? So question number 111. So what they are saying is, we have an input action and we are applying to it Hn. So impulse response Hn of a system we are given, and output will be Yn. Yes, is applied as an input to LTI system with impulse response Hn. So Hn is 2 del of n minus 3, and what we are asked, the output at n equals to 4. Okay, so we know output is going to be convolution of these two, that is xn convolution Hn. Okay, so y of z we can write then x of z, and h of z, okay, and x of z we are given, this is x of z, and hz we can find. So from this, if I take its z transform, so h of z will be 2 z to the power minus 3. So if I multiply this, so xz is this, and let's multiply. So xz is z to the power 4 plus z square minus minus 2 of z plus 2 minus 3 z to the power minus 4, okay, and hz we found 2 z to the power minus 3. Now let us find overall y of z. So y of z is going to be 2 z to the power 1 plus 2 z to the power minus 1 minus 2 to the 4 z to the power minus 2 plus 2 to the 4 z to the power minus 3 and minus 3 to the 6 z to the power minus 7, right. So this is at n equals to minus 1, this is at n equals to 1, n equals to minus 2, n equals to minus 3, at n equals to minus 7, and we are asked a value at n equals to 4. So at n equals to 4 there is no term of z to the power minus 4, so that value will be 0. So correct option is B. Now let us go to next question. The dominant mode in a rectangular waveguide is TE10. So TE10 mode, its frequency gives us the minimum cutoff frequency. So minimum cutoff frequency, or we can say highest cutoff wavelength, or highest cutoff wavelength, right. So what we are asked, the dominant mode in a rectangular waveguide is TE10 mode because of the highest cutoff wavelength. So D option is correct. So question number 113, in the circuit shown below, the power supplied by voltage source is. So we have to find out how much this voltage source is supplying. How much power this voltage source is supplying. So let us see, I current is coming out from here, then power supplied 113. So power supplied will be I into V. V is 10 volt. So we have to find out I, then we can find out power, how much power this 10 volt is supplying. So to find out this I, this 1 ampere is coming, 2 ampere is coming, then in this one 3 ampere will be going. So I is going, so this will go I plus 3. So this is coming I plus 3 and 1 went there, and then this is going to be I plus 2. Right, now let us apply here KVL, then you will write 10 minus 112 ohm. So 2 into, and current into ohm is I plus 3. Similarly 112 ohm and current in this 2 ohm is I plus 2. So minus I plus 2 into 2 ohm equals to 0, right. So let us write 10 minus this is 2I minus 6 and minus 2I minus 4. So 6, 4, 10, or this 10 will be cancelled out, then 5 or this 4I is going to be 0. So I will come out to be 0. If I is 0, then power delivered or power supplied is going to be 0. So correct option will be A. Now let's go to next 114. A linear discrete time system has a characteristic equation we are given. So question number 114. So characteristic equation we are given, that is z to the power minus 3 minus 0.81 z equals to 0, right. So let's find out its roots. So z, if I take common, this is going z square minus 0.81, okay. So z into z square minus 0.9 square, okay. So roots are going to be z equals to 0, z equals to 0.9, and at z equals to minus 0.9, okay. So in z transform, if this is our unit circle, then roots are, one pole is at z equals to 0, another is at z equals to 0.9. So this is 0, this is 0.9, and this is minus 0.9, okay. And this is let us say z plane, then this is going to be mod of z equals to 1. We draw this unit circle. Since all poles are inside the unit circle, then ROC will be including this unit circle, then it will be a stable system, right. So it is stable. Now let's go to next question. Question is 115. In the circuit shown below, the effective resistance in ohm faced by voltage source. So this voltage source, how much resistance will be facing? So from looking this voltage source, we have to find out resistor, right. So this I current is going there, then same current will be coming from this I also. So our aim is to find out this Vs by I, right, and that is going to be Rs. So this much resistance will be faced by this voltage source, right? So let us find it out. So we know I current is going there, I by 4 is coming, then from there how much current might be coming? This would be 3I by 4, right? Then only 3I by 4 plus I by 4 will be 4I by 4 is I, right? So let us apply KVL now. So this is going to be Vs, okay, minus 4 into 3I by 4 equals to 0. So Vs by I is 3. So correct option will be 3. A option is correct. Let's go to next. So next question is 116, and this is question again from signal and system from Z transform. So the question is the region of convergence of Z transform of unit step function. So if unit step function, that is xn is un, we know its Z transform will be x of z is going to be z upon z minus 1, because we can assume here 1 to the power n, okay, and ROC mod of z is going to be e to the power n un, and a is 1, so this is going to be 1. So ROC is going to be mod of z greater than 1, so correct option will be A. Now let's go to next question number 117. A group first list a set of 4 transfer functions, and group second gives a list of possible step response yt. Match the step response with the corresponding transfer function. So you might be aware of the response of second order system, that is this is what, of underdamped, this is undamped, this is undamped because it is not damping, right? So this is undamped, and this is the fastest response, this has to be critical damp, and this is slowest response, this has to be over damp, okay. So in critical damp we know zeta is 1, in under damp zeta has to be less than 1 or greater than 0, and in undamped zeta has to be 0, and in over damp zeta has to be 1, okay. Now let us find out the zeta from the given transfer functions, and then we can easily select which system is having response which one, okay. So this is 117. In the first question we are given CS by RS. CS by RS we are given is 25 by S square plus 25, and standard CS by RS. So standard transfer function of second order system, we know this has to be omega n square by S square plus omega n square plus 2S zeta omega n, okay. So this is 25, and you can say in case of P, this is our P system, right? So in case of P, zeta term is 0, right? Because 2 zeta omega n term is not there, so zeta has to be 0. So this has to be what? Undamped. This has to be undamped system, right? So this P will be undamped, and undamped is third. So P has to be matched with third response, okay. Similarly, in case of Q, if you check, this is going to be 36 by S square plus 20S plus 36, right? So omega n square is going to be 36. So from this you can conclude that omega n is going to be 6, right? And 20S is going to be 2 zeta omega n into S, right? So 20 is going to be 2 zeta omega n. From this zeta omega n is going to be 20 by 10, 20 by 2 is 10, and zeta is going to be 10 by omega n is 6. So this is coming greater than 1, so this is over damp, right? So Q will be matching with over damp, this is 4. So Q will be matching with 4. So Q is matching with 4. Let us check out option. Q is matching with 4, and P is matching with third. So P is matching with third, Q is matching with 4. So correct option will be D. Similarly, you could check R and S also, but from these two options only we can conclude the answer, right? So let's go to next question number 118. So this question is again from analog circuit. So the question is, we have to find out V output, okay. So let us see, this is our V input 1 volt, and positive feedback is there, and input is given. So this is Smith trigger, and that too input is given at positive terminal, so that is non-inverting. This question is 118, and this is non-inverting Smith trigger, okay. So non-inverting Smith trigger, let us see. So this is going to be V output, and this is let us say Vf, feedback voltage. Okay, so let us apply KCL here. So Vf, outgoing current, is Vf minus Vi by how much, R, okay, plus Vf minus V naught by R, right, and equals to 0. So no current will be going in positive and negative terminal of this open, right. So this is going to be cancel out, and this is going to be 0. So this is going to be 2 Vf equals to Vi plus V naught, okay. Then we know V out can be either plus V saturation or minus V saturation, right, and we know the Schmidt trigger, its V output versus V input curve is like this. So this is what, this is non-inverting, then this is going to be in anti-clockwise direction, okay, this will be like this. But you know, this is upper threshold, UTP, upper threshold point, and this is lower threshold, this is V output and this is V input, okay. So we know that at lower threshold point and at upper threshold point, where there is a transition, our V plus, that is positive terminal voltage, has to be equals to negative terminal voltage. We must know this, and if we apply this condition, then V negative is 0. So V plus, that is nothing but Vf. So Vf will be 0. So if we put Vf 0, then this is going to be Vi plus V output equals to 0. Okay. So V output is going to be minus Vi, and Vi is 1 volt. So from this, V output is going to be minus 1. So correct option will be A. Now let's go to next question number 119. The question is, which of the following components are used for bias compensation in resistor circuit, in transistor circuit? So actually this is from a compensation technique topic. So this is not in GATE syllabus, so we won't be dealing this. Now let's go to next and last question. This is question number 120. A 10-bit digital to analog converter. So number of bit we are given 10 and DAC, okay, gives a maximum output. So maximum output or full scale output, we can say this is 10.23 volt, okay. The resolution, we know resolution. So resolution, if you check out the options, resolution is asked in volt, and if resolution in volt, so resolution in volt is nothing but what, this is step size, right. So resolution in volt is called step size, and step size is V reference or V full scale output voltage divided by 2 to the power n minus 1, okay. So this is 10.23 divided by 2 to the power 10 minus 1, this is 1024 minus 1, 1023. So this is going to be 10.23 divided by 1023, right. So this is going to be 0.01, that is 10 millivolt, okay. So correct option is A. With this we complete the technical part of this 2016 paper. So this is all about this video. We will end this video here. Thank you.